Hello there, and welcome to this video on rational equations. So we've already looked at simplifying rationals, we've done adding and subtracting, as well as multiplying and dividing. So today what we're going to be dealing with now is with equations. So there's going to be an equal sign somewhere, and this I would say is actually easier than say like adding or subtracting rationals. So a rational equation is an equation containing at least one rational expression. So there's at least one fraction where we have, say, some x in there. We're going to have to solve for that x. So here's an example of a rational equation. The steps that we're going to be doing are very similar to what we've always done in all of our rational stuff. We're going to factor everything first, then state our non-permissible values. Those are the exact same steps as we've always done. Then, this one's kind of new, we're going to multiply both sides of the equation by the denominator factors. So whatever we have in the denominators here, we're going to multiply by those, and it'll actually remove or get rid of all of the fractions. So that's why I said this is actually going to be a little bit easier than, say, adding or subtracting, because those ones still had denominators. In today's stuff, the denominator is going to disappear. So once we've done that, then we're going to solve by isolating the variable on one side of the equation, so just like how we normally solve. And then at the very end, always check for extraneous roots to make sure that none of them are extraneous. So looking at number 1 there first, we got a 4 and an x in the denominator, so neither of those we can factor, and none of the numerator terms we can factor either. So I can go straight into step 2, identify the non-permissibles, or we also call those restrictions. So the restrictions in this case, this has no variable, so I don't have to do any restricting there. Here though, that x cannot equal 0. So that's our only restriction. X just can't equal 0. So if I get an answer in the end where x equals 0, I know it's definitely extraneous. So we're on to step number 3 now. Multiply both sides of the equation by the denominator factors. So I'm going to multiply everything by what's in a denominator. So everything is going to get multiplied by a 4 and an x. So this will get multiplied by a 4 and an x. This will get multiplied by a 4 and an x. And this too will get multiplied by a 4 and an x. Now a lot of those are going to cancel. Like this 4 and this 4 will cancel. This x and this x will cancel. So what we get out of this, there was an x times an x there in the first part, so that's going to be an x squared. Then we had minus 7 times 4, so that's going to be minus 28, so minus 28. And then equals, and here we had 3 times 4 times x, so that's just 12x. So now we don't have any denominators. Now I can just solve this how I normally would, so I'm going to subtract 12x from both sides to get that 12x gone on that side. So I got x squared minus 12x minus 28 equals 0. And then to factor that, we're going to do our product and our sum. So the product is negative 28, and then the sum is negative 12. So two terms that multiply to negative 28 and sum to negative 12. That's going to be negative 14 and a positive 2. So it breaks apart into x minus 14 and an x plus 2. And then we still have equals 0. Don't drop this equals 0, because if you drop that, it's no longer an equation. So solving this one, you'd take x minus 14, set it equal to 0, add 14 to both sides, but you can see we're going to get x equals 14. And then same kind of thing with this one, take x plus 2, set it equal to 0, subtract 2 from both sides, we'll get x equals a negative 2. So those are our solutions, 14 and negative 2. If you wanted to verify, you could plug them back in to verify. Looking at number 2 here now. So step 1, we're going to factor everything that we can. So in this denominator here, this is a difference of squares. So that's going to give me a y minus 2 and a y plus 2. Then we got plus 10, can't factor or do anything with that, so keep it as it is. In the denominator though, I can factor out a 6, so I'm left with a y and a plus 2. Another hint, guys, I had said this before in another video, but whenever you see kind of one factor pop up, don't be surprised if you see that factor pop up in another location. So we have that, and then equals 1 over y minus 2. So there's again another repeating factor. So now that everything is factored, I'm going to do my restrictions over here on the left. So from this, I'm going to have y minus 2 cannot equal 0, so therefore y cannot equal a positive 2. And from this, y cannot equal a negative 2. And then these ones are just going to repeat those ones. So what I'm going to do, rather than stating y cannot equal a positive or negative 2, I'm just going to put those together and put y cannot equal positive or negative 2. Back to solving this now. So we got everything factored. What we did next was we multiplied by all of those denominator factors. So I'm going to multiply everything by a y minus 2 because there's a y minus 2 here. So I'm going to do that in every single one. Y minus 2, y minus 2. And then what I'll do is I'll actually cancel out all my terms that can cancel. So this one and this one can cancel, and this one can cancel. Because that way I can see whatever is left in the denominator, that is still what I need to multiply by. So like this y plus 2, they all need a y plus 2. So right there, give that one a y plus 2. And then this one over here also needs a y plus 2. And then we can do canceling. So that one can cancel with this one, and this one can cancel with that one. And then the only other term we have left in the denominator is a 6. So I'm going to multiply as well by 6, 6, and 6. So in this one, it will cancel out. So now we can write what we have left over in our numerators. So in this one, there was a 2 times a 6. So that's just going to give us a 12 plus. Then we had a 10 times a y minus 2. So I'm going to multiply that right away. That's going to give me a 10y. And then a 10 times negative 2 is negative 20. Then we got equals. And then this last one, I got 1 times y plus 2. So that's just y plus 2. And then I got times by 6. So I'm going to distribute the 6 into that bracket, and I'm going to have 6y plus 12. So I'm going to take that line of work and I'm just going to move it up over here. So next what I'm going to do is I'm going to try to get all of my y's on the left side and then all of my numbers on the right side. So I am going to subtract 6y from this side and then also from this side. It's going to cancel on this side. And then I'm going to subtract a 12 and add a 20. And then do that here as well. Subtract a 12, so those will actually cancel, and then add a 20. And then these canceled as well over here. So all that we have left on the left side is this 10y minus 6y, so that's going to be 4y equals. And then on the right side, the only thing that we had, these all canceled, but we just have a plus 20. So we got 20. And then to solve that, just divide both sides by a 4. Divide by 4. These ones will cancel. And so we get y equals 5. And then again, with that answer of y equals 5, you could check and see if it's extraneous by plugging it back into the equation. Or you can also just look at the restriction. It's not one of these values, a positive or negative 2, so y equals 5 is the answer. We got one last question here now, number 3. So first step, let's start to factor everything. So in the first one, can't do any factoring, just leave it as it is. So denominator, k plus 2. The next one, can't factor the numerator, k plus 1, so leave that. Can't factor the denominator. Then we got equals. So this one, we got a product of 24 and a sum of negative 4. So you could try to factor that, but that isn't factorable. So you can just leave it as k squared minus 4k plus 24. And then divided by, and then this is the only thing that we can actually factor. K squared minus 4, that's a difference of squares. It's k minus 2 and a k plus 2. So now that everything's factored, let's do our restrictions. Always do that right after you've factored everything. So from this one, k plus 2, you could take that, set that equal to 0, and then subtract 2 from both sides. You're going to get k cannot equal a negative 2. This one you'll do the same kind of thing. So k minus 2 cannot equal 0. Add a 2 to both sides. We get k cannot equal a 2. And then these two just repeat the same thing, so we don't have to bother doing those. And then again, rather than writing these as two separate restrictions, I can put it all into one. I can say it's k cannot equal a positive or a negative 2. Back to solving now over here. So everything's factored, so let's multiply by all of those factors in the denominator. So I'm going to multiply this one, everything by a k plus 2 and a k minus 2. That's in brackets. This middle one here, got to multiply that by a k plus 2 and a k minus 2 as well. And then same thing for the last one, k plus 2 and k minus 2. So now that we have all that, let's do our canceling. So this k plus 2 can cancel with that, k minus 2, k minus 2. In the middle, k minus 2 and k minus 2. And then on the left, we got a k plus 2 and a k plus 2. And then just so I don't make any mistakes, I'm going to put these two terms here in brackets so that I FOIL correctly. So what we're going to get out on the right, everything canceled over here except for this big piece in brackets. So I'm going to have k squared minus 4k plus 24. On the left over here, I got 4k minus 1 times k minus 2, so we're going to have to FOIL that. We're going to have a 4k times a k. That's going to give us 4k squared. Then we're going to have a 4k times a negative 2. That's going to be negative 8k. Then we got a minus 1 times a k. So that's a minus k. And then a minus 1 times a minus 2. That's going to give me a positive 2. And then I have a minus, so I'm going to put minus. And then in brackets, we're going to put this multiplication here. You always want to put brackets so that you don't forget to distribute that negative into the brackets. So I'm going to have a k times a k, that's a k squared. I'm going to have a k times a 2, so that's 2k. I'm just going to write this over here. And then I'm also going to have a 1 times a k, so that's another 1k. So altogether I have 3k. And then the last multiplication, we got a 1 times a 2, so that's just equal to a 2. I'm just going to fix my equal sign, move that up there. So now that we've done all of that canceling and multiplying, what we can do is start to simplify everything that we've got here. So like these k's, I can put those together. So I got 4k squared, that'll give me minus 9k plus a 2. And then here I'm going to have to distribute this negative into each of these terms. So I'm going to have a minus k squared, a minus 3k, and then a minus 2 equals, and then all of this is just staying the same on the left side. So at this point now, I'm going to start to move everything all onto one side. So I'm going to minus k squared, I'm going to add a 4k, and I'm going to subtract a 24. And I'll do the same on this side. So minus the k squared, plus a 4k, and then minus a 24. So on the right, all of these are going to cancel, and the only thing I have over there is now a 0. On the left, I got a 4k squared minus a k squared, so that's 3k squared, and then minus another k squared, that is going to be 2k squared. For my k values, I got minus 9k plus 4k, so that's minus 5k, minus another 3k, so that's minus 8k. And then for my constant terms, I got a plus 2 and a minus 2, so those will cancel out. And then there's just a minus 24, so we got minus 24. Now that we've gotten that, what we can do, all of these terms here on the left have a factor of 2, so I'm going to divide everything by a 2. So you'd have to divide this by 2, this by 2, every single term would have to get divided by 2. So we're going to get k squared minus 4k minus 12 equals 0. And then from that we can do our product and our sum. So the product is negative 12 and the sum is negative 4. So two numbers that multiply to negative 12 and they sum up to negative 4. So that's going to be a negative 6 and a positive 2. So what we get is k minus 6 and a k plus 2. And that's still equal to 0. Don't forget that it's an equation. Okay, so take this one, set that one equal to 0. So k minus 6 equals 0. Add 6 onto both sides, we get k equals 6. And then from this one, take that, set it equal to 0. And then subtract 2 from both sides, so we get k equals negative 2. So our two answers, we got k equals 6 and k equals negative 2. But if you recall, we said k cannot equal a positive or a negative 2. So this value right here, we actually can't have. So we have to cancel that out and say that this is extraneous. So that was our last question. At the bottom here now, I'm just going to write our textbook questions. And then one final really important note that I want to make here, guys. Whenever you're doing questions like this with an equation, you're allowed to do this multiplication where you get rid of everything in the denominator and basically all of your fractions go away. You can't do that when you are adding, subtracting, multiplying, or dividing fractions. Okay? The only time you can completely get rid of all of your fractions like that is if it's an equation.